Okay, so in the fourth RStudio activity, we're going to be completing the 3 standard deviation band approach using RStudio. So for this activity, you're actually going to be downloading a third file. So not Jenny, but this one is just ed.csv. So again, I'd recommend saving it to the same file location as the other Jenny or Jenny AB. You can either download them from the SSD analysis website or directly from the 793 website. So once you have that download complete, this first same 3 steps as the other activities. So just copy and paste out require SSD for R. Paste that into RStudio. After that's run, find your comma separated value document. And you're going to be looking for this ed document here. And as always, just make sure that you attach that after you've opened it. And now it's attached. So, okay, so after finishing those first few steps, the third step is to create a graphical representation of hospital admissions using the X-bar range chart, which is essentially just a 3 standard deviation band graph. Conceptually, you can read more about it in your textbook, but it's basically taking the bell curve and turning it on its side. So we can see the upper band. In the graph below, you can see the upper band is 1 standard deviation above the mean, and the yellow line is 1 standard deviation below the mean, with the green line in the middle being the mean here, which is the average. So I am just going to copy and paste this out and run it in RStudio. So now that I've run it, you can see that the mean is 73.94, and then you can see the upper band and the lower band, which is, again, 1 standard deviation above and below the mean. And we can see that the graph is labeled by number of weeks on the bottom, the x-axis, and the y-axis is the mean percentage of admits per week. And these are social-related admits. So if you're to label, we're going to have to do this step by step here. So I'm going to just add the labels. You can see the example below. So I'm just going to do this step by step. And this is just to separate the baseline from the intervention. So we're going to want to click here between the stop of the baseline and the beginning of the intervention at week 7. So that creates the distinction between baseline and intervention. And just to make sure that you don't copy these all out at once, you have to do them step by step. So this is just to label each one of the values. So I can paste that there and accept it. And I'll do that for the next 3 steps. And anytime you add these labels, they're going to look just a little bit different than mine. So when you submit your graph to D2L, that's actually a good thing. So I can kind of just spot check to make sure that you're understanding this. So the 79.32 is 1 standard deviation above the mean. 73.94 is your mean. And then the last text that I'm going to add is the lower control limit, which is 68.56. And there's no real right or wrong way to place these labels, so don't try to put any pressure on yourself to make them look like I have in the example posted to the assignment. And then the last step, this just creates a legend for the upper control limit, lower control limit, and mean. Just creates a legend, and that's it. So the same thing with the exporting the graphs, just the same way you've done it the other way. You can just click on export, copy to the clipboard, copy plots, and if you want to, you can save this in a new Word document and submit this for your final assignment. So you can just submit it into a new Word document. And then and then the last point here that I'd like to highlight is I'd like for you to try to attempt to answer these last two questions. So just if you can see any data points that are above or below the lower or upper control band in the baseline or the intervention phase. So hopefully you'll be able to write that up and then kind of just point out where you see them, and then just submit that to for your final paper. And again, more conceptually, just to kind of point this out, the reason that we would do this graph as opposed to some other graphs is that this graph shows us if there's any specific data points that are statistically significant. So for your paper, you aren't necessarily going to need to do this unless there's a good reason why. But it's still a good thing to be aware of just in case you would ever want to use this moving forward. So again, if you're thinking about the bell curve, this kind of turns it on its side. We can see, for instance, the upper control limit is 1 standard deviation above the mean. So it looks like just about all these points in the baseline, except for maybe one, are above the upper control limit, telling us that most of these are statistically significant. Versus in the intervention phase, you might only see one or two that are within 1 standard deviation of the mean. So here we can see that there's multiple points that are below the lower control limit. So as opposed to a t-test, which we'll be doing in activity 5, this just tells us if one specific point falls outside of what would be expected by chance alone, or something that's statistically significant. So again, you can read more about it in your textbook, but I just want to give you maybe one more tool that you can use moving forward with your practice of single system design.